Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches along with your class 9th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 9th, our ongoing chapter, fluid pressure. And today we are entering into the session number 3. Means so far we completed 2 sessions about the fluid pressure. In first class, we learn about what is fluid, right? What is fluid? What is pressure separately? What is fluid? What is pressure in the session number 1? Then second class, the reason for the fluid pressure, the density, relative density we learn in the second session. Correct? What is density? What is relative density? Then we introduce about what are the types of fluid pressures. Just we have introduction. So either it is maybe the liquid or gas, because we know out of all the states of matter, solids, liquids and gases, so far both liquid and gas have the ability of flowing. That's why the both together called as fluid. Fluid is a matter which flow. Okay. So these fluids have capacity of flowing and also they have capacity of exerting the pressure. The pressure exerted by liquid or gas is called fluid pressure. So this fluid pressure, whether the body is, how much pressure it is exerting on the one over the other, it depends on mainly on the density. Density plays very important role, whether the body is shrinking in the liquid or whether the body is floating over the liquid. So yesterday, if you remember, we have seen one wonderful video also showing about the 3 liquids. One is flowing over the other. And when you are dropping the various objects, like it may be of ice cube or grape or a bottle cap, how they are shrinking in one over the other. It is floating in one substance and shrinking to other subject. All these things are depends only on the density of the body, with the density of solid, liquid or gas. It plays very, very important role in the fluid pressure or important role in the floating of the bodies. So we'll continue today where we left in the last class with what are the various types of pressures exerted by the liquids or gases, or mainly liquids we discuss. Then what are the different devices we'll use to measure the pressure. Various pressures are there. Okay, that we'll discuss today. So this is the basics what we learned about the thrust and pressure of the fluids. So far what we learned. So you all know that the fluid thrust is nothing but force only. Force acting perpendicular to a particular body is called thrust. The thrust by area, thrust acting on unit area is called pressure, which is measured in Newton per meter square or is also measured in Pascal. So many other units also there for this, like bar. See, bar is there. 1 bar is equal to 10 power 5 Pascal. Bar is also unit of the pressure. Then we discussed about what is density and relative density. You know, density is nothing but mass per unit volume. Mass per unit volume is called density. And because for water, the density is highest at 4 degrees Celsius, which is 1 gram per centimeter cube or 1000 kg per meter cube. And the density of other liquids measured with respect to water, that comparison is called relative density. The density of liquid to the density of water at 4 degrees Celsius is called relative density or specific gravity, which has no units and no dimensions. Right? So up to that, we are clearly learned about the fluid and pressure. Now we combine them. When you come to the synopsis 3, that is fluid pressure. So the term fluid refers to any substance which has no definite shape and has to flow, ready to flow. So liquid and gases are fluids. Since they have no definite shape and can flow, the pressure exerted by the fluid is called fluid pressure. So many where you can see the fluid pressure. Not only practical examples, we can see our day-to-day example also. Suppose when you are going by cycle or biking, when wind comes against you, so how much pressure apply on you? To move forward, you have to overcome the force of the air. That is called a pressure of fluid only. While swimming, you can see how much pressure the fluid exert. So you have to overcome that. By overcome only you can the pressure exert on the aeroplane or car or train. To overcome, then only they can move forward. Otherwise, we cannot move forward or cannot fly or we cannot swim. All these are the pressure exerted by either liquid or gases called fluid pressure. So when you come to the part of types here, a fluid exert pressure in 3 types. One is downward pressure, upward pressure, and lateral pressure along the direction. So there are 3 types of fluid pressures we can experience, we can see, we can note also. So first you can see downward pressure. Take a glass tube, open at both ends, right? Take a glass tube, open at both ends. The thin rubber sheet on the one end. This is thin rubber sheet here. You have to place that open end on rubber sheet. Hold the tube vertically and pour some water into it. The balloon bulge out of the showing that the water has gone down. And that is, it exerts the pressure on the rubber sheet. Add more water to the tube, the bulging increases. Simple. You can take the balloon and place it in the tap. In tap and open the tap slowly. Observe how the balloon will bulge. Because as the water is going down, exert the downward pressure because of the root. So from this we can conclude that water exerts the pressure on the bottom of the vessel it is kept. Right? Exerts the pressure at the bottom, that is called downward pressure. Second one is upward pressure. Take a football and immerse in the water in the vessel and leave it. First you put it inside, press it and leave it. It will come up immediately. Why? Because of the upward pressure exerted by the liquid. Correct? It's a commonly observed. You can throw ball also. It will bounce back. Why it is bouncing back? Because of the upward pressure. So fluid can exert downward pressure, upward pressure. Correct or not? So many where you can observe this one. Not only this example, you can observe this in the various applications. Now, third one is lateral pressure. Lateral means sideways, sideward pressure. You can see simple example. So take the balloon, fill the water and make holes at the side. From each side you can see it comes out with a great pressure because of the pressure exerted by the fluid or water. Okay. So this is the 3 kinds of pressures: upward, downward, and lateral or sideward. Lateral. 3 pressures, right? Clear. Simple with balloon experiment also you can see all these things. Next, mathematical expression for the liquid pressure. So what type of pressure liquid exerting? We can give the mathematically also. A beaker is filled with the fluid having density D. Right? So whatever it may be, liquid, water or any other fluid. Imagine cylindrical column of the liquid with the horizontal area A at the level B. So there is A and B are represented here. So levels. Level B is mentioned here. So this is the area we consider where it is touching the liquid, where the pressure is acting of the liquid is the area is here. Okay. As the depth h below the surface. So from here it is what is the idea? Depth is h. Okay. So volume of the imaginary column of the fluid. So V is equal to area of cross section into height. Volume is equal to volume formula. Area of cross section into height. Well, how we got it? Volume is nothing but length into breadth into height. But what is length into breadth is taken as area of cross section. Correct? So volume is equal to area of cross section into height, because area of cross section height are given here. Okay. So A into H, capital A generally taken. So that is equation number 1 we got. Then the thrust on the cylindrical column is nothing but weight of the liquid. Liquid acts in downward direction. So weight of the liquid is nothing but M into G. We know the formula. Weight is given by mg, right? Here is given. But what is M? From the definition of density, mass by volume. So mass is equal to density into volume. So from equation 1 you can substitute here. So from thrust is equal to A into H into rho into G. Substituted here. Total. In equation 1 we substituted. Okay. Then pressure is equal to thrust by area. So you got the thrust and area is A. A will cancel. So we got rho GH. So pressure is equal to rho GH is the formula. So rho is nothing but density, acceleration due to gravity, height. So based on this only, the pressure of the liquid depends. So it depends on the density of the liquid, acceleration to anyway constant, height, how much depth it is from the surface. So the formula for pressure is rho GH. Pressure of the liquid is rho GH. It is obtained from a simple two definitions. One is from thrust, right? Other is from the volume. Rho GH is a very important formula. Okay. So that is the mathematical expression for the pressure exerted by liquid. Pressure exerted by liquid is given by P is equal to rho GH. Rho is nothing but density of the liquid into acceleration due to gravity into height. How much height is from the bottom. Right? Clear? Right. Now move. When you move to the next part, after knowing the mathematical formula of the pressure, what is the total pressure at the point in the liquid? At one, because we have so many pressures will act upward, downward, lateral. Then what is the total pressure? Right. The total pressure at the point B, suppose we consider the point B here, is equal to atmospheric pressure of the surface. Right. And pressure of the liquid, both will act. So there is atmospheric pressure also acts from the dot. See here. On the surface of the liquid, the pressure of atmosphere pressure is very important. That also acts as well as the pressure of the liquid. That is given by PA plus PGH. We know. So suppose atmospheric pressure is given by PA plus rho GH, already we know the formula. So the total pressure is equal to P total is equal to, on any liquid, the total pressure acting is atmospheric pressure plus pressure of the liquid, that is rho GH, which we have derived previously. So the total pressure is nothing but PA plus PGH. That's what given here. Right? That GH can be another way. G into H can taken as some other value that will come across later. So the pressure exerted by the liquid is nothing but P is equal to rho GH, whereas the total pressure acting on the liquid is, one is atmospheric pressure acts in the downward direction as well as the pressure of the liquid. So PA is atmospheric pressure, the constant value is there, and rho GH. Total pressure is given by PA plus rho GH. Then pressure in fluid. Some other way is explanation is there. In fluid, the pressure exerted by the fluid is defined as the force per unit area at a point of the fluid. At any point you can find out. right? So like that you can find out for the disk. For disk they calculated it has a force by area only. Whenever force is constant over the surface, the above equation reduced to P is equal to F by A. There is no change. If change is there, delta you can use. Delta F by or dF by dA. See what is 1 atmosphere? 1.06 pascals. So some conversions are there for the pressure. So 1 atmosphere is nothing but 10 to the power of 5 pascals. Or 1 ATM is equal to 1.01235 bar, another unit of the pressure. Right? So these are the conversions for finding out the pressure of the liquids. So expression also given here, liquid pressure. How to get the liquid pressure, expressions, total pressure. We have seen already P plus rho GH. Okay, so before going for the Pascal's law, let me show you one video on the types of the pressures. After knowing about types of pressure, move to the next part, that is very important, Pascal's law.
Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out. We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, rho equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid. The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box. So H2 is bigger than H1. Because P equals rho GH, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force upwards called the buoyancy force or upthrust. If the buoyancy force is greater than the weight of the object will rise up through the liquid. If the buoyancy force is less than the weight of the object will sink. If the buoyancy force is equal to the weight of the object will still float.
Right, the pressure, how the wind sink, wind slides. Right, clear. The one more video is there based on the Pascal's law. Before going for that, we'll see this.
New car for servicing. Sagar was interested in the machines and their functioning, so he waited and watched the process. He placed his car on a platform. An engineer went into a room and pushed a lever with his foot, and the platform suddenly rose with the car. He was astonished to see this and asked the engineer how he did that. Are you equally excited to know what happened? Let's see what the engineer said. The engineer said that this is the application of Pascal's law. Let's see what that means. Two cylinders are underground and both are filled with a hydraulic fluid. One of them is a narrow cylinder beneath the engineer's
This is the
wheel,
hydraulic machine.
and another one is a
Used with
wider
the cars.
cylinder beneath the car. Observe that cylinder P has a piston attached to the lever and cylinder Q has a piston attached to the car platform. It connects the two cylinders at the base through a pipe. A valve is present in this pipe. When the lever is pushed, the valve opens because of the pressure in the fluid. The liquid rushes from cylinder P to
Oh,
cylinder
the car is
Q.
lifted. While servicing, they'll do this.
This results in a rise in the liquid's level in cylinder Q, which pushes the car platform along with it. When the car has reached the desired height, the lever is no longer pushed. Now, the valve is closed, so the liquid does not flow back to cylinder P. That's how hydraulic machines work.
Hydraulic.
The term hydraulic itself means
Pressure
a
gauge it
liquid
called as.
moving in a confined space under pressure. Another interesting thing about these machines is that the work done while pushing the lever is equal to the work done pushing the car up. But the distance covered by the effort is much more than the distance covered by the load. This is because the effort is much smaller. So the force is small and hence displacement must be large so that the work done matches with the work of lifting the heavy load. So the next time you go to the car garage, you know how the car is lifted just by pressing the lever. Now Sagar's car is ready and he is driving back home. You return to your class and continue the lesson.
Right. So interestingly simple way they show what is the pressure exerted. So how the pressure will exert on car. I already told yesterday only. That is when you go to the car station happens that is also called a pressure gauge, hydraulic machine. Anything you can call it as. It is a hydraulic machine. You know, hydraulic means water. Hydraulic machine which works with the pressure of exerted by the water. So car servicing stations or even car servicing will be done with that. Already I told seeds, oil seeds are crushed. Oil seeds are crushed by this hydraulic machine. It is also called pressure gauge. Okay. So Pascal's law. So you know total pressure is given by pressure of atmosphere plus rho GH. Depth of H fluid maintained. So according to the Pascal law, a pressure applied to the confined fluid at rest is transmitted equally undiminished to every part of the fluid of the wall. So the pressure exerted by liquid is distributed equally for all the areas. When you apply the pressure, it distributes equal to all areas. See here, we are applying pressure from small force. We are applying small force, but as the pressure is expand to all areas, it exerts the force at the maximum area. Means small force can become the big force because it is spread throughout the area. That is called a principle of, so you know pressure is equal to force by area. F1 by A1 or F2 by A2, whatever it may be, because both are same. So you can get F2 value. What is the force exerted is nothing but A2 by A1 into F1. Means when you apply the, suppose you are applying the 5 Pascal force, but it will come out as a 10 Pascal. The force is increasing. That is called the Pascal's law. Because of the distribution of the force equally all areas. Okay. So there are so many types of forces are there, not only the fluid force, we have the atmospheric pressures. So many pressures like atmospheric pressure, absolute pressure, and gauge pressure. Atmospheric pressure is nothing but pressure exerted by atmosphere. In atmosphere, you have the pressure, which is force by area, is given by the value, or it is also called 76 mm. 760 mm of Hg, atmospheric pressure of mercury, or 76 centimeters also of mercury, because it measures the atmospheric pressure with the mercury barometer. That's why it is measuring of Hg. 760 mm or 76 centimeter atmospheric pressure. Then absolute pressure, that is the total pressure. Atmospheric pressure plus the pressure of the liquid is called pressure of the fluid is called absolute pressure. So atmospheric pressure is nothing but the pressure exerted by air column on unit area of cross section. So because we know that atmosphere also exerts the pressure, that is called atmospheric pressure, which is given by 760 mm of Hg or 76 centimeter. Absolute pressure is nothing but atmospheric pressure plus original pressure by the fluid. That is P0, P atmosphere plus H rho G. That is called total pressure only. Right. So the pressure which we measure our automobile tires is a gauge pressure. So there are different types of pressures we can see in our. So see, there is a gauge pressure. The excess pressure measured with the help of the pressure measuring instrument called gauge pressure. Okay. So there are different types of pressures you come across: atmospheric pressure, absolute pressure, gauge pressure. And the gauge pressure is always measured by manometer. You know, the manometer is a very important. There are so many are there. Barometer used to measure the pressure, atmospheric pressure. Manometer used to measure the gauge pressure, and their barometer is there. Okay, these are C missions given. How the manometer works, how the mercury barometer works. You learn in the lower classes how to construct the mercury barometer, how to measure the pressure by using the mercury barometer. Just names are enough for you, right? So pressure is of, it may be the atmospheric pressure, absolute pressure, gauge pressure. So manometer used to measure the gauge pressure, barometer used to measure the atmospheric pressure. Right? See, these are the very wonderful diagrams showing the how to measure the pressure. Pressure can be measured with this, either it may be air pressure or liquid pressures, can be measured by using these particular manometers and barometers in pascals. So this is what we learned today about the types of pressures, and followed by the Pascal's law and application, how it is used for in the car servicing station. So whenever you are applying the force on a liquid, the liquid pressure exerted distributes equally through areas, equally distributes. By applying the some pressure from minimum force, we can get the maximum force from the other side, by which you can see the car servicing. We can use for the crushing of oil seeds into oil by the machine. Right? Hydraulic machines are used. With the help of pressure of liquid, it is applicable. Okay. So, and different types of pressures we have seen. We have seen the expression for the pressure. P is equal to rho G H. Rho G H we have seen. And total pressure is nothing but atmospheric pressure plus rho G H. Is also called absolute pressure. So for calculating the atmospheric pressure, there is a mercury barometer. For calculating the gauge pressure, there is a manometer. That is the devices which you can measure to use the pressure. Right? So that's all for today about this chapter. So thank you very much, all of you. Have a wonderful day, a wonderful weekend. Thank you.